I'm Heather. I'm going to be the tech facilitator for this session. So if you have any questions or difficulties, you can send me a message on the Zoom chat. So the session is one of the expertise connection sessions, and it's titled Interactions with AI Systems, How Do We Avoid Risk and Bias? It was designed for leaders in the Circles community to share information and examples with participants who want to learn about the topic. And to also provide a forum for participants to discuss how they might incorporate the topic into their work. And last, to foster connections between community members around a topic. So I hope as you're going through this, you can also think about any takeaways that might apply to the strategy sessions tomorrow, which will be kind of open-ended discussions for brainstorming, following up on this topic. So there's going to be four presenters today. They're each going to present for about 7 minutes, and then we'll have a chance to regroup and come together for a discussion. So the first speaker is Kylie. I'm going to turn it over to you.
Thank you, Heather. So my name is Kylie Pepler. I'm situated here at the University of California, Irvine, and I have a joint position in both informatics and education. And so as a learning scientist, this is kind of a nice position so that we can study and design new technologies and think about the impacts on learning and theory. Today, I want to talk to you a little bit about some of the work that we've been doing around AI, makerspaces, and opportunities for automated assessment. For those of you that are sitting in the out of school world, you know, assessment is a big challenge because we need to defend what's happening in out of school spaces, but we don't want them to look like school spaces. We don't want to bring in, you know, typical kinds of assessment practices. Go ahead and go to the next slide. So part of what we've been doing is looking at portfolios. And for a long time now, we've thought about portfolios as assessment measures because they can capture a richness of production-centered learning. You know, they're increasingly part of the job and higher education applications. But there've been challenges to scaling portfolio assessment, largely because the costs and time associated with scoring and talking about looking at those portfolios. And so as we think about harnessing the sort of the AI revolution, what can we do with assessment? And you know, a few of us here are kind of thinking about how we can use AI to power, you know, power machines to function with higher intelligence levels. How could we emulate, especially in assessment portions, what human capacity is for scoring and for assessing? And it has a huge potential to transform and leverage the amount of data available in educational contexts. And so I love, you know, to kind of really think about myself as like a forensic scientist of learning, like what can I do without adding anything to the environment, but just pick up on sort of like what's the data that's already there? What are the kids wanting to do? What are we wanting to do as educators in that environment? How can we leverage all of that potential data seamlessly? And so, you know, my lab and some of my collaborators, we've been exploring how to use AI to deepen these portfolio assessments. And maybe this could all lead to sort of a vision where, you know, if we think about the, you know, we think about standards or we think about competencies, how could we start to assess them and show people all of the things that they learn and all the things that they've been learning in real world context to start to satisfy these things, but also start to build on this and offer kind of smart feedback for the next lessons. You can go ahead and next slide. So in our makerspaces, there's all sorts of new tools, not tooks, sorry. And there's all sorts of new tools for learning that are starting to transform what we've seen. So kind of what are our first steps in doing this has been a lot of our work to think about how do we assess that learning. And we can't build an AI model if we don't know exactly what that learning looks like in person. So we got to kind of return and think about building these assessments. And then we can start to build models of these human ways of doing these assessments. So I just want to show you an example of that and then how we've extended that. All right, so go ahead. And this is through my early career work. So in makerspaces, a lot of times, we've been stumped in the field for a long time. So go ahead and go to the next slide. Not just how to assess it, but this conundrum here around understanding basic electronics and things like current flow and polarity and connections and circuits. It's been riddling the literature for decades now that kids just can't learn this content. This is like undergraduates, this is the foundational kind of ideas for engineering and physics and elsewhere. So we've been looking more closely at this. So if you are just, kind of scratching your head and wondering about this kind of piece here, current flow is really just that the current needs to go in a circle. So it needs to kind of start from the battery and return to the battery in any type of circular shape. The polarity, that it needs to run from high to low, so the positive and negative side of the battery, that there is a directionality to a circuit, and that these connections need to be tight. Go ahead and go to the next one. So a lot of times we assess that through, circuitry diagrams. So we've looked at classical kits like Hand to Mind down here, and you might remember this from your education, of a 9-volt battery and a little light bulb and a switch that's like a little guillotine and some of these things. But there's all sorts of new circuits that are changing, and now you could sew your circuit, you could squish your circuits together with Play-Doh and replace that wiring. You could snap them together with magnets and little bits or snap circuits, and so that's changing the way that we're learning and engaging this content. Go ahead and go to the next slide. So we've been developing new assessments, and these are based on sort of what we know. So we test this understanding through circuitry diagrams, but we've been trying to make them more playful in educational spaces through stickers. And so you can kind of see how you might demonstrate this understanding of the pre-test and the post-test. You can also see how the kids are starting to get at those big concepts. You can see the loop starting to happen, the connections are considered, that the directionality of the circuit is also considered there. And so we're able to score these and look at this. I would just share a little bit of sort of what that looks like. So go ahead, next slide. Yeah. So, you can see some improvement from the pre to the post test. Go ahead and just click forward. Yep, next slide. And so it's interesting, we had all the kids sort of train in one of the kits and then show differences from pre to post tests of this sort of large study that we had. And it was interesting, and go ahead to the next slide. All 4 of kind of the new kits showed gains from pre to post, and the existing kit that's most widely used in schools, it's almost institutionalized. The existing kit showed no gains. And so it's interesting, as we looked at that result and we look back on the literature, it's not clear that kids were ever learning with these kits. And so as learning scientists, we need to look more closely at our tools and materials. We need to really test them and not just assume that learning is happening. But this kind of led to us to kind of think that we've got a pretty good assessment here. We know what's happening. We know kind of across these kits, the circuitry is just one of the many things we're looking for, but it's a nice example. So go ahead and go to the next slide. So now how do we build on this understanding? We've got a nice assessment. How do we start to automate it? Go to the next slide. So we've started building these models. This is together with my colleague Seth Corrigan, who's at Southern New Hampshire University. The AI starts to make it possible to assess these pieces at scale. So we can start to embed these in our maker spaces. But you can see how we can take actually images that would be in the portfolios. We could start to create models of this that can kind of sense whether this photograph had actually created a working sewable circuit, what kinds of competencies might be learned, and be able to build them over time. So go ahead and go to the next one. And so, as we start to look at this, start to build these models, we're doing this around images and we're doing this around circuitry assessment, but there's a whole wealth of things that we could be doing with AI to start to look at a range of artifacts. This could include sound artifacts. This could include, written kinds of things. This could be other images, other types of STEM types of learning, other types of art learning, all sorts of things that could be part of this. And then if we think about putting this competency, embedding it in video. This could also be part of our, sensing of our everyday environments, especially in maker spaces, without even having to create the portfolios of work over time. All right, thank you. Go ahead and go to the last slide. I'm happy to chat with you more today. Later, I'm interested in knowing more about how you're thinking about assessment in your spaces and how we can start to automate these assessments over time.
Okay, so I'm next. My name is Carolyn Rose, and I'm a professor of language technologies and human-computer interaction at Carnegie Mellon University, and I'm now the interim department head of the Language Technologies Institute. And I'm going to talk about conversational agents, facilitators of collaborative groups. And I am so happy to be positioned after Kylie's talk, because I think there's a real synergy between the kind of work that she introduced and the kind of work we're doing here in my group. Although it looks kind of different because I'm in a different subject domain, different age group, and yet there's this idea of automated assessment, of sensing, of processes, and what can be learned from how people are building artifacts together, and even are they actually learning from the activities that they're engaged in. And I'm going to focus on software development, where there's a huge belief that if students are sitting in front of a computer writing code, they must be learning something. And yet we find that that's not always the most valuable learning activity for students in their even like heavy duty software focused classes like cloud computing. But in what I'm going to present, some of the work that I'll talk about is work that we've been doing for the past 15 or more years, but other parts are things that we want to move into. And as I'm spanning between the past and the future, I'm going to bring in just issues that I think might connect up with what some of you in the audience are working on: opportunities, challenges, and risks, as our desire is to be able to support learning among low SES or minority learners. Okay, next. Okay, so I'm going to focus on a vision that we have for being able to offer opportunities to students in a community college context. And this leverages some great work one of my colleagues here is doing, Majd Saker, in terms of developing curricula that that bridge from work that started here at CMU, but now is being adapted and offered in community colleges, and in particular with the focus on helping people pass certifications that would enable them to get higher paying jobs. And so we have these courses, and we've been doing studies in terms of being able to support learning during collaborative software development. And the hope is that this work can be used both to help people more quickly and effectively get to more high-paying jobs, but also to continue learning in the workplace. So we haven't, done the work situated in the workplace yet, but we're situating our support for learning in industrial strength software development environments like AWS Cloud9 and VS Code LiveShare, because these are environments that people continue to work in once they're in industry. And so if we can support their learning in the classroom in these environments, the support could still be part of those environments when they are doing their work. Next. So for the past 15 plus years, we've been doing work largely in purely online, largely in purely text-based interaction environments, supporting collaboration in a context-sensitive way by continuously monitoring collaborative processes through that text-based chat and offering scaffolded support for the processes in the chat. But recently, we've expanded this into the multimodal space. Here you can see a pair of students working on a software a project together in this 3D environment where sensors are listening in and watching how they're interacting with one another. And the support is being offered through a virtual human positioned on a screen in the room with them rather than in a text-based chat. And yet the scaffolding around the collaborative processes can be just the same as what we had in the text-based environment, because we use the same architecture for the continuous monitoring and the triggering of the support. And you can see some of our papers on this past work on the side. what we're trying to identify now is how we have to be careful in how we're doing the monitoring as we're watching how people are interacting in a more multifaceted, multimodal space, because there are more aspects of how people interact that could trigger cultural stereotypes that can be very easily picked up on as you train machine learning models to do the process monitoring, because there could be spurious correlations between demographic groups and learning outcomes or problems in collaboration. And so when mannerisms come into play as people are interacting, those stereotypes can be triggered in a machine learning model just as they are with humans. But we have seen a lot of success with the kind of support that we can trigger through continuous monitoring in our chat-based environment. We would like to be able to use that effectively in this 3D environment that we now have the ability to start to really seriously experiment with, but we want to be mindful of these risks. And so it's thinking about these opportunities, challenges, and risks that I want to bring to you today. Next slide. Yes. So here's an example. Oops, sorry. I go back one. Thank you. You can imagine that with the ability to monitor in a 3D environment, students working together on a software development task, we might be watching a group such as what you see here. And you can imagine a kind of situation occurring like the following. So Joey may make a demeaning comment to Felicia, and Cody, another student in the group, may laugh. And so what should we do here? Well, in our past work where we have seen such negative affect being exchanged within groups, we've seen that the students who are the target of this behavior often do not feel comfortable anymore taking a risk to try something that they might not be good at, or if they try and make a mistake, they're less likely to come back and try again. And those are the places exactly where the students need to come back and try again. When we have introduced interventions that break the tension and help students to get past this negative affect, students who are the low ability students who are often the ones who are the target of this negative affect in their collaborative groups are able to come back and try again on those things that they really need the help with. And so they learn significantly more when you can detect and break this tension. Now, this, you could say, amounts to nothing more than a sentiment analysis task, and there's been a lot of work on that in language technologies. But oftentimes in groups, especially with adults, it's not so obvious that people are exhibiting these negative affect behaviors, because there can be sort of very subtle, sarcastic comments that are nevertheless very, very hurtful to people, and can serve to kind of make people feel bullied and pushed to the side. And so it causes us to ask again, are we capturing the most important part of that signal of how well the collaborative processes are working? Next slide, please. Part of what we need to do in order to ask ourselves those questions is to get inside of the models that we're training and to understand better how the decision making is happening. Neural models have been criticized for being opaque, and yet there's been a huge amount of work on interpretation and visibility in the language technologies community and also in other communities of machine learning. One of my PhD students, James Fiacco, is working on a technique for factorizing neural models in order to identify what he calls neural pathways that help us to kind of get a more abstract view of what are the major pieces of knowledge that are coming into play in making decisions in order to kind of take inventory of the kind of decision making being made in order to sort of allow us to ask ourselves the question, how are things being detected? Are the important things being taken into account? And is there potentially harmful triggering going on? Next. So back one. So here's an example of where it could be harmful triggering. So let's say that within a data set, it's easy to imagine that there are certain demographic groups that might characteristically have come from less well resourced school districts and might have certain struggles when it comes to learning STEM-based content. And yet that's not universally the case and shouldn't be assumed. But as we have this continuous monitoring taking place, sometimes those characteristics that set apart those groups could be noticed by models as correlating with needs for particular kinds of support that are sometimes not needed. And just like a sarcastic comment that puts someone down might cause them to shut down, treating a person like, they need help when they don't feels like that person is being treated like they're stupid. It's almost as bad as calling them a name. And so it can be very, very harmful if these stereotypes, like students from demographic group X have less math skill and therefore need more help on that front. Those things, if they are learned through models and those things are not detected, it's possible, especially when in our testing data, those categories of students might also be less well represented. Those problems might go unnoticed if we weren't looking for them in particular. Go ahead and click. And so again, what we might want to do is be proactive. If we can identify these neural pathways and associate them with knowledge, we can look to see if there are ones that are picking up on stereotypical associations between mannerisms that are culturally associated and certain kinds of outcomes. Go ahead and click again. So for example, we might notice that there are features of let's say, a vernacular form of English that the model might associate with needs for articulation support. Even if these features are by some regarded as disfluencies in language, they don't necessarily mean that a person is less able to make their reasoning clear. It might just be a residual characteristic of their speech. And so these things like using, like IMA as a, part of their language should not cause the model to assume that support for articulation of reasoning is needed by the student. A better path of reasoning would be that if we don't see elaboration, if we don't see extended explanations, if we don't even see attempts at explanation, that might mean we need to draw a student out. That might mean that student might need help constructing their arguments. We should make sure that what's triggering the support is actually a detected need and not just something that might frequently in the data be associated with that. And again, getting visibility into the decision-making that's going on in the models might allow us to check for these kinds of risks and mitigate them because they are risks. I can tell you that language is so multifaceted and the models to do detection for things like the need for certain kinds of collaborative support or for certain attitudes that are being expressed, those rules that get learned bring in so many features that aren't directly related to the constructs, but are just features of the language that help the models get high accuracy. And it's extremely important to be able to look to see what are the dangerous aspects of any particular model that get trained so that when they're used in an environment where there's the risk of creating an environment that's not conducive to learning for specifically those groups that we would like our interventions to support, it can undercut our ability to achieve our goals if we're not careful. Click. So here we contrast what could very well happen, the kinds of things that are risks just because of what happens when you train a complex model with data that contain lots of low-level predictors that are weak and easy to get to in the language. A harmful side effect could be that the usage of vernacular triggers unneeded support for articulation of reasoning. I mentioned that. A better approach would be that articulation of reasons in connection with ideas should actually trigger pushing the student to go further, to build on that, to challenge the thinking of her peers, because even if she exhibits some of the behavioral characteristics of other students that need one kind of support, that would be just a speed bump to her that she doesn't need, and she should really be encouraged to take the next step. And so the answer here is to get a deeper look into these models of assessment, to be able to try to do model selection in such a way that we can pick ways of doing the detection that not only give us high performance on whatever data we're validating them on, but specifically mitigate the risk that certain students in particular demographic categories might be inadvertently harmed. Click. And so we can't magically fix the problem that machine learned models have these bias issues. It's a topic that gets discussed a lot today. We have a lot of insight into what about our sampling and modeling and representation can lead to these risks, but oftentimes there's this struggle that if we cut out those spurious correlations, that the performance necessarily is lower. And there are ways that as a field, we're working on overcoming those barriers. But at the moment, what might be the best we can do is use an approach that gives us this insight into what's happening in our models better, to do model selection and know explicitly what the trade-offs are that we're making, or know in what kinds of situations we can trust which models, so that we can put appropriate safeguards in place, perhaps in the way that we implement the support, so that we can try to avoid having it come across in a harmful way, or avoid detecting certain things we don't want to detect, make a concerted effort in certain contexts, maybe to introduce additional models that specifically look for problematic circumstances that we detect. That sounds messy and half-baked, and partly it's because it's work that we're still doing. But what I wanted to do with this talk is to highlight that these are issues. They build on a foundation of what we can achieve, but they surface issues that we still very much do need to deal with, and which are very much important to consider in collaborative contexts where social interactions bring these kinds of identity issues and sensitivities and insecurities to the fore, at the same time as they offer so many rich opportunities for learning support. Click. And so I'm going to leave it there and allow anybody to ask more questions. This was really meant to be more provocative than just a report of what it is that we have achieved. So go ahead and raise more issues for discussion. But I think we'll move to the next speaker now.
And I believe that's me. So hi, everyone, and thanks for coming. I'm Anthony Botello. I'm an assistant professor at the University of Florida in the College of Education associated with educational technology and computer science education. So I have a background in computer science and AI, but have been applying that for several years now of building educational tools. And one of those tools I'm going to be talking about today as pertaining to this project that's been ongoing now for a few years, referred to as Driver Seat. And the idea of this project is really trying to create teacher-facing tools, and specifically human-in-the-loop tools, or teacher-in-the-loop tools, as we've been talking about them, as ways of kind of supporting the teacher role in the classroom to promote communication between teachers and students and improve learning in general. But on the next slide, this idea of this driver's seat project, aside from just being this project and the $1 million acronym that I will offer as an achievement in itself, is again really focused on this idea of helping teachers to better understand the data that's being collected about students and offer them ways of taking action. And this has led to a number of projects. So I'm only going to focus very specifically on one of these tools that has emerged from this project called Quick Comments. And this particular tool is really designed to help K-12 teachers, specifically in a mathematics domain, address student answers to open-ended problems. So a lot of educational technologies are really good at helping students and teachers as well of providing feedback and automated assessment to a lot of closed-ended problems of multiple choice, fill in the blank. You all are probably very familiar with this kind of style. But there's been a lot of need, and certainly this was vocalized by a lot of the teachers that we were working with on this project, that there aren't enough supports for these kind of open-ended problems. A lot of teachers are spending a lot of manual labor and a lot of time going through reading tediously to provide feedback to students. And a lot of the information that we get from teachers and students surveying is students also really value the feedback that they get on their work. And they want more. But again, it takes a lot of time. So on the next slide, I kind of give an example of one of these open-ended problems, just to kind of give you an idea of what we're looking at. Traditionally, these would be following in a lot of curricula that are openly available. These types of explain your reasoning problems tend to follow one of these kind of closed-ended problems where the student might figure out what the value of, in this case, the scale factor from polygon A to B, and then they're asked to kind of explain how they got that, got to their particular numeric answer. So again, teachers are relying on these types of problems in the classroom to really assess kind of the deeper understanding of the concepts, being able to make sure that students are able to articulate using mathematical terminology, that they understand the concepts and aren't just kind of procedurally just plugging in the numbers in a kind of set of equations, and they can assess the student understanding to a deeper level with these. But again, it takes a lot of time for teachers to go through this. And on the next slide, I kind of included a few examples pulled from this problem from the data set that we had, just to kind of illustrate the variety of answers that we tend to get. And again, there are varying ways of expressing this. So some students, one student said, because B is 2 times biggest than A, which you can kind of assess that the student was able to understand the mathematical concept, but of course, kind of linguistically, it's different from another student who might say 2.5 times 2 is 5, kind of recognizing the answer. So effectively, a lot of these students are saying semantically or meaningfully the same thing, but express that in various different ways. So again, it's really important for a tool that is helping to potentially automate this assessment to kind of recognize that there is going to be this large variation and be able to offer perhaps ways that teachers could, again, better maybe address these student answers. Next slide, please. So really the goal of this Quick Comments tool, which I'll kind of give a snapshot of in just a slide or two, there are really 2 goals. So we wanted to, again, help teachers score these answers. We want to help teachers assess these student answers because we want to help them save time. We, again, have heard from a lot of the teachers that we've collaborated with on this, that they spend hours upon hours every night looking through these student responses. So if we can save them a few seconds per student answer, that's already going to accumulate to a large impact. But even beyond that, it's not just the act of helping them assess these students. We also want to help direct them to the right kinds of feedback that would help these students learn. So the kind of secondary goal of this project is also to help provide feedback and take action in this to help guide students in the right direction, not just give them a numeric score, but tell them maybe how to improve. And that's exactly then what we built into this tool. And we drew inspiration from an existing technology that kind of already helps users respond to other users. And if you click on this, you might be familiar with Google's Smart Reply. So if you use Gmail, or this is also exists now in several technologies for like email or conversational agents, the thing that is trying to recommend how to respond to a particular email, that technology is what we tried to kind of draw inspiration from of what this smart reply technology is doing from Google is reading through the email virtually, trying to understand what the message is of that email, what the content is of that email, and then offer a way that other users have found effective in responding to that. So we kind of drew that analogy of wanting to help teachers, again, kind of read through student answers, understand the content of those answers, but then also then offer suggested ways that perhaps other teachers have responded in the past, or if we can learn more effective ways, perhaps even suggest more guided ways of, you might want to say this, but you might want to instead rephrase it in this particular way, of maybe offer, again, ways of improving the delivery of that feedback as well. Next slide, please. So just to give, I'm skipping over a lot of detail. There's a lot of work that's kind of gone into the building of the AI that I'd love to talk about, but definitely don't have the time to. So feel free to reach out after this, this session if you want to know more of specifically how this was done. But this kind of gives a snapshot of kind of what this looked like within a learning platform before. And this learning platform was Assessments, for those familiar with that technology. So what we did is we built in then a new tool, if you click, that basically extends this interface that required manual grading to now add this kind of, again, smart reply inspired UI that offers now suggested ways that teachers could provide feedback, but also it's not clear from this, but it's also making recommendations to the score. But it's important that this technology is not actually inputting or directly sending this to the student. It's treating the teacher as a very important role within that process. The teacher is the one making the decisions of what ultimately gets sent to the student. So the teacher is, even though we suggest an assessment score and we suggest some messages, the teacher is the one that's ultimately making that final decision. And again, it's perhaps saving a couple of seconds, and we have some empirical results that are at least suggestive that this is doing a good job of actually saving time. But there was also a large impact on just the perceived time. Teachers were a lot more willing to spend the time providing the feedback, knowing that there were some supports there. And in many ways, the tool itself has helped teachers kind of respond to or automate the responding to students who do really well. So the kind of 100% students, and the students who do really poorly. So the students getting 0, which already then allows the teacher to maybe focus the majority of their time, even if they're spending the same amount of time overall, they can focus their time more directly to the students. In the middle, where we, as the tool itself doesn't really know how to respond maybe to some of those students in the middle of the pack, the teacher can direct their attention and spend more time for those students where it might have larger impacts. Next slide, please. So that's the tool itself, but I kind of want to kind of pivot into some other potential problems that come out of this, and to kind of characterize that, a kind of deeper understanding of what goes into a tool like this is needed. So at the base of this particular tool, we're using some existing methods in natural language processing. And if you're not up on the latest NLP research, that's perfectly fine. Basically, all you have to understand is a lot of these methods are really just trying to figure out ways of converting text, like the sentence that we have here, into a numeric form. And many of these kind of existing methods that are freely available now try to do so in a way that maintains some semantic relationship between words or between sentences, such that if you were to plot these words, words that show up closer together in this embedding space should be closely related to each other. And again, this is now, there's a lot of research that is built up to this. This isn't the novel kind of portion of the tool. But there have been some problems that have emerged as a result of this type of this method. If you go to the next slide, there have been some known biases already detected in a lot of the what are called pre-trained word embedding models that are made available. So some very common ones that you might have heard of if you're familiar with the space are Word2Vec or GloVe. More recently, there's Elmo, BERT, and a few other Sesame Street characters. A lot of these methods have, again, been trained on very large corpuses of data. A lot of these have been kind of pre-trained based on, say, Wikipedia or Google News, and released openly to the public to support NLP research. And these, some of these are what's powering that quick comments tool that I was talking about. But there's this issue is that there have been biases that are detected. So in the paper that I kind of linked there, Man is to Computer Programmer as Woman is to Homemaker, basically what was found is that there are a lot of occupational biases, there are a lot of gendered biases, there are a lot of racial biases between the relationships of words that emerged from the data that these pre-trained embeddings were trained from. So even though they were trained from things like Wikipedia, just nuances within that data set has led the model to think that there is a closer relationship between the word man and the kind of word or phrase computer programmer, and there's a perhaps farther distance between woman and the same set of words. And again, there's kind of some research that has kind of identified this problem, and there's some other research that has tried to mitigate this somewhat unsuccessfully, but this is kind of a known problem. So this kind of raises then a kind of larger question of, since we're now employing this type of methodology within this student-facing assessment tool, if you could click on that, even though the embeddings are biased, does that mean that an AI system that is going to use those embeddings is unfair? And that's maybe a very kind of nuanced question, but that's really what we have done some work, and is still kind of an open-ended question that we have yet to solve by any means, but one that I think is driving a lot of the future of this research and has been driving it really since the beginning of the project itself. Next slide, please. So really, it's this idea of there's a cycle of the data that we are that is used to train these models is being implemented into these AI systems, and then these AI systems are being used to be shown to real users, or in this case, real teachers. And then the teachers interact with those systems and generate new data, and the cycle continues. So if there is bias within data, or there are kind of these odd relationships within data, such a system can kind of perpetuate that bias. An AI system might learn bad things from data that might then influence teachers, that might then perpetuate those kind of decisions further, kind of causing this bad cycle. But an AI model itself is not implicitly biased. A random forest isn't a biased model, or a logistic regression isn't biased. It learns that from data. The data itself is where the potential issue emerges. And bias isn't always a bad thing. It's sometimes good to kind of recognize that there are differences between kind of subpopulations or subgroups within data that can be helpful to a model in some cases, or helpful to an AI system. But it's when that bias might lead to unfair or inequitable results that it starts to then become a problem. Of when students are saying the same thing, but using different words to express that, of even comparing, we've been looking at decimal usage versus fractions within these answers, where we might have numerically equivalent answers, but expressed in various different ways. And making sure that the model is making the same type of prediction for both of these types of answers is something that's really important. Next slide, please. So what can we do? So some kind of approaches that we are taking right now are really starting with the data, trying to understand where the data comes from that we're using to train these models, where the data is, how we can characterize the data. Part of that is paying attention to protected groups, so things like gender, race, location, but there are a lot of kind of nuanced, more abstract groups that emerge of fraction users versus decimal users. And understanding all the ways that we can split our data to look for potential differences has certainly been a challenge. And I think we've done a good job of maybe picking out some kind of theory-based ones to look at first. But I think there is still kind of an open question of what are the right groups to look across when looking for things like unfairness within these assessment models. And again, I think we've done a good job of looking for that, and we've have yet to find anything significant, luckily, but certainly you don't want to deploy this type of a tool without at least having some kind of a safeguard. And that's also, I think, some strength of a human in the loop system of having at least the teacher as part of that vetting process of making sure that what the model is producing is reasonable or somewhat sane. Having the teacher's expertise as part of that loop, I think, helps this process, but it's maybe not perfect. And certainly the teacher might trust the AI tool more than they should, or perhaps distrust it if they ever find that it does produce something that's kind of ludicrous. So these are all kind of challenges that are fresh on my mind, certainly as I approach this project and take it into the future. But yeah, these are some just open questions and still a lot to do here. And I think there's one last slide. So thank you. Yeah, if anyone wants to learn more about this project, again, I've glossed over a lot of detail, but I'd be happy to talk more. Feel free to reach out at any time. Thank you.
Hi, everyone. Can you hear me? Great. So I'd like to talk just a little bit, and I'm actually going to ask Heather if she wouldn't mind. I'll try to compress my talk to about 4 minutes, just so we can have a teeny bit of time for a micro discussion. If you wouldn't mind telling me, Heather, when 4 minutes is up, or maybe 3 minutes and 45 seconds, we'll go for that. Click, please. Interestingly, there's this really curious thing. So there's this thing called game-based learning environments. And many of us have been working on these technologies for probably 10 or 15 years. And there's a lot of really interesting results that are coming from them. But they're almost always designed to be solo. And by that, I mean, they're designed for a single student to be sitting at his or her desk by themselves, and it is not the most sort of nurturing kind of interaction that you can imagine. So for something like 5 years now, collaborators, and click please, at Indiana University and with my group have been working on collaborative versions of game-based learning. So principally, this is a partnership with Cindy Mello Silver, who is a great colleague and an expert in computer-supported collaborative learning. Lena Saleh, who is a postdoc. This particular work I'm going to be mentioning is by Dan Carpenter, as a PhD student in my group, with also contributions from John Rowe, Andrew Emerson, and Brad Mott. And I'll also say that there's a parallel line of work that's going on by Kyungjin Park, who is this K that we see here in our video. So hi to Kyungjin, and thanks for your contributions as well. Next slide, please. So this is the solo version I was talking about. Lots of great things to say about it, but next slide. Oops, that's 2 slides. 1 slide back, please. What we would really like to see is a classroom that's like this. And in fact, for about 5 years, we've been working on this scenario. So imagine instead of having a solo game-based learning environment, you have groups of kids that are working together. So we've been creating a multiplayer game that students use in a kind of inquiry fashion in ecosystems. So it's designed for middle school. And it's a particularly fascinating area of study, I hope for the kids as well, but what I really mean is for the researchers. So we designed this to, in this very, very iterative fashion, we've gone through so many different versions of this game, understand what it means for kids to collaborate. So what does it mean for them to coordinate? What does it mean for them to make meaning together in this particularly deep way? And of course, the wonderful thing is there's this data exhaust from all of their interactions, which is the discourse. So there are kind of two forms of this. There's the chat-based that we are capturing at a very minute level. And then there's the spoken language, which we've just begun thinking about how we might use these together. So you might be thinking, well, gosh, if they could just talk, wouldn't they do that? And it turns out they actually do talk and chat in ways that, at least to somebody of my age, is a little bit unexpected. But that's the way that is quite natural to them. And if you can go to the next slide.
Okay, so we have hit 4 minutes. I don't know. Do you have one more slide?
I will do the impossible and wrap up on slide number 3, which is to say that we've been for a couple of years now looking at models for recognizing different phenomena in collaborative discourse in this game-based learning environment. We've looked at off-task behavior. So there's some interesting results that are coming out on that. Kyung-Jin has been looking at some similar kinds of things. But I'll just say that there is so much opportunity here, not only because the interactions are so rich, but because the language itself is so rich. And just a sort of forward pointer that I think there's going to be a lot of work in this area over the next 4 or 5 years as we come to really understand how not only does this sort of play out in real time, but how can we facilitate it? How can we promote the most effective kinds of collaborative learning? So thanks.
So can we thank all of the speakers while I'm trying to exit this? All right, thank you so much, all 4 of you, for your presentations. And thank you, James, for making room to have a very short Q&A. So is there anyone who would like to ask a question? Presenters, you can also ask questions to each other.
Yeah, I like this as a tension, around the work, and certainly AI, presents so much possibility and so much tension. James, and the work that you're doing with Cindy, what could go wrong? What are you trying to steer in the right direction there?
There's different levels of what can go wrong. So there's what can go wrong with the kids themselves. As we saw in earlier talks today, bullying, for example, or really not such cutting kinds of comments, but comments that are really having the side effect of kind of putting people down. And just in general, this is something that Kyung-Jin has been working on. But then there's also, we can go wrong if we facilitate incorrectly, like we saw from Carolyn's work. If you learn facilitation moves that are based on, among other things, language models, as we saw from Anthony's work, that are biased, you can easily learn models that are going to facilitate incorrectly and exacerbate inequities as opposed to improving the situation. So there's issues with the data, there's issues with the learning phenomena, then there are issues with the models that we learn to scaffold or support.
Thank you. And so there's a question here on automation needed in assessment in the context of maker spaces from Arij. And how it adds to the pedagogy and interaction in the space. A lot of times, especially in maker spaces or in informal spaces, there's not there's not as much training, right? And so you have instructors that haven't been trained in these things, that they're oftentimes both the admin staff and the teaching staff. And so they're usually doing some administrative work while the kids are learning, in an area. So that a lot of self-paced work is happening. So I think assessment becomes important in these areas, especially for self-reflection, because then you know what you're doing and why you're doing it. And if you think about sort of building these models, it can also make smart suggestions for what to do next. Like, for example, when we were doing sort of the original design development of Scratch, kids were creating games and they wanted to have a counter, but they hadn't realized that they could leverage variables to do that and to keep score, right? And so, you know, a skilled facilitator could go in and talk about that, but also could be something that that our assessments could say, hey, you're building a game, you know, do you want to add a counter? And here's what's happening, right? And so you could build off a lot of that embedded assessment. So, you know, a lot of the data that we're using for the model, sometimes we're trying to tune it to things that we're assessing of, you know, kind of artifacts that are there. With AR technologies, we can sort to sense what's on the table, even to assess if people aren't holding a tool correctly or if they haven't put a safety feature down, right? So we, you know, we're starting to do that, especially around welding, around a lot of other things where safety is a concern. And then we're also kind of looking at the back-end analytics and how do we start to leverage those things to encourage the kinds of behaviors that we want to see in online spaces and in you know, in some of these platforms. So thank you for the question, Arish.
I had one really quick question for Carolyn, and it's I mean, I really enjoyed so many of you raised so many interesting things to think about, and I just trying to understand, Carolyn, in the trigger detection you're talking about, what are the kinds of responses? Like, I'm trying to understand the scope of the problem. Is it the AI agent is responding, or is it kind of triggering a person to, like, in a group to respond?
Oh, so the general way that that our systems are set up is that we're constantly monitoring the collaboration to trigger conversational agents to come in and offer scaffolding. And each one of those agents is focused on scaffolding to overcome a particular kind of difficulty. And so they're all designed to offer some positive form of support. But if you offer support when it's not needed, it can come across as demeaning and discouraging. So there's the danger of doing that, but then there's also the danger of missing a problem to address because it was subtle. So I think that there were issues on both
sides. Yeah. All right. I do see it's 5 o'clock, and so we should probably let people go. And also, just a quick reminder, if you are going back to SwapCard, there is like the welcome opening remarks are going to be delivered right now in SwapCard. So thank you so much to all of our speakers. And if you're available, come to the strategy session tomorrow to continue this discussion.
Yes. Thank you, Heather.
Thanks very much, Heather.
Yeah.
Thank
Thanks
you
for attending. Bye.